most of that up at 1559, that doesn't solve the problem, but that makes the problem a lot simpler. In my blog, I've outlined not a solution, but possible building blocks of a solution. These aren't the only possible building blocks of a solution, but they basically require both sides to give a little bit. And the GPS people have staked out a position on the Save Our GPS website that any solution has to be acceptable to them as the arbiters of good taste. And I point out that since the 1934 Act, decisions on spectrum have been governed by the public interest, not a particular set of users who want total veto power. And secondly, that it should have no impact on GPS. Now, does that mean that any GPS receiver that's in existence now should be able to work for the next 10 years, 20 years, 30 years? Unless you think I'm unrealistic, there's an analogous adjacent band problem just above the FM broadcast band. FM broadcast goes to 108 megahertz. At 108 megahertz and above is the FAA's instrument landing system. The instrument landing system is vulnerable not to one FM signal, but to pairs of strong FM signals that are near an airport. You can avoid that with better receivers. There's a trade-off. You can't always avoid it, but you can make receivers more robust. Since 1992, ICAO, the International Civil Aeronautics Organization, a UN body like the ITU, has adopted receiver standards for instrument landing system, which are mandatory in international aircraft navigation. Everyone in the U.S., at least in the FCC side of the U.S., assumed that FAA would mandate that quality of receivers for U.S. aircraft. Well, it turns out the airline industry has them, because if you didn't have those receivers, you couldn't fly to Canada and Mexico, and no one would buy an airplane, a 747, that can't fly to Canada and Mexico. But the general aviation business, the charter planes and the personally owned planes, have a lobby comparable in effectiveness to the National Rifle Association, and has comparable control that the FAA that the NRA has in certain places, and they hate to obsolete any equipment. And even though it's been almost 20 years since ICAO adopted those receiver standards, FAA has never mandated them, so the whole burden of avoiding the problem is on the FM broadcast industry. Now, reasonable people could disagree on how to distribute the burdens, and the way public policy decisions are reached are basically distributing burdens among different people in a fair and equitable way, which is not objective, but it's subjective. That's why the commissioners at FCC are political appointees appointed by the president with the advice and consent of the Senate. These questions are not scientific questions. You solve problems by compromising, weighing costs and benefits, balancing interests, balancing burdens. And in the instrument landing system case, the FAA, under pressure from AOPA, has insisted that they can continue to use that worst ILS receiver ever sold, and the FM broadcast band is still managed, protecting those receivers. And it's interesting to see the same AOPA is active in this thing. And the question is, if you have a $5,000, $10,000, $15,000 receiver in an aircraft, how long should you expect to use it? And frankly, while your GPS receiver in your car will never be upgraded over its lifetime, and indeed, if it ever breaks, you'll just throw it away, when you buy commercial electronics in the $5,000, $10,000, $15,000 price range, the concept of upgrading it over its lifetime is not so unreasonable. It has real costs. You can't do it overnight, but one could imagine that the car-type GPS receivers will improve over the next 10 years, particularly as an incentive to do so, and B, that the other receivers that don't have as fast a turnover, at some cost, could also be improved, particularly the ones that cost $5,000, $10,000, $20,000. The ones used in airplanes are not the same as the ones used in cars. They have somewhat different functionality. They receive the same signal, but they do other things besides receiving the signal. But they could conceptually be upgraded at a real cost. And the question is the balancing of interest between the costs and the benefits to every party. Letting spectrum lie fallow also has a cost to society. Is it an overwhelming cost that negates all other issues? No. But it's in determining the public interest, there are a lot of competing public interests at stake here. And so the answer to this is nothing an engineer can calculate using a formula. This is a case where you need presidential appointees who have confirmed the advice and discuss that. It would be nice if they understood the issues a little bit more, but you know, that's why we're deciding in this forum.
Which is becoming a little more clear to me that there is technology that could solve some of the receiver concerns. There's also both sides.
I would say that move them in the right direction.
Okay.
Solving is a strong statement.
Okay.
There could be a balancing. You know, one of the solutions is how far does light squared stay at 1559? They have 6 megahertz. They're absolutely forbidden to use. They can put that 6 anywhere. But they may not be able to spend it all at the GPS border. But there are other tricks they can do. Another trick that they can do, the Garmin report that led to all the scare factors basically assumed that they would build an antenna that radiates in all directions exactly the same. Imagine like a star shining, radiates light in all directions. Okay. If you look at cell phone towers, for example, even the ones that are commonly used today, they have funny antennas. They don't radiate equally in all directions, either in azimuth or in elevation. Now, they're not very complex in the elevation distribution, but there was a controversy a decade or so ago between a company called North Point that wanted to share spectrum with DirecTV, and one of the things we learned from that was about 10 times higher in frequency, that it was important for them to coexist to control the power such that the power received on the ground was small and uniform over the whole service area. And particularly since there's a risk of interference to aircraft, it's very important for this type of thing to make sure that the amount of power radiated in the air, and certainly above the horizon where aircraft are, but even somewhat below the horizon, that attention has to be paid to the spatial distribution of their antennas. And in the Garmin report, they neither took account of the 6 megahertz that can't be used, some or all of which could be at the boundary, or the fact that the light squared could and no doubt should be required to carefully control in the sphere surrounding their directions which parts of the sphere are well illuminated and which parts get minimal illumination. And at much lower frequencies like FM broadcast band, it's very difficult to control that. But the size of an antenna is inversely proportional to the frequency. The wavelength at this 300 megahertz wavelength is 1 meter, 3 gigahertz, it's 10 centimeters, so this is 20 centimeters. The wavelengths are like this, and building something which is 10, 20 wavelengths is not huge. So it might be more cost than Verizon and AT&T and T-Mobile spend for antennas, both for the cost of the antenna and when you rent space on a tower, the total vertical length of your antenna structures. The towers are generally owned by third parties, and from the highest point to the lowest point of your antenna, that difference is how much space you're renting, and if you need more, you got to pay more. But there are ways by putting in more complex antennas, not to solve the problem, but these are building blocks to get things under control. There is no simple magic bullet that makes these problems go away, but there are building blocks. The building block is the receivers getting better over time, and building blocks is playing with what block they don't use, controlling their radiation. One could imagine transition plans where they start in with a more conservative use, and as the receiver population evolves, go to more aggressive use. But I think ultimately that the receiver population is going to have to evolve in immunity, and must admit I'm thoroughly puzzled why, what has happened since 2004 when this thing first started bearing its ugly head. What has the GPS industry done in anticipation of this problem? In the FCC thing, much too much money is spent on public relation agents, somewhat by both sides, but there seems to be too much aggressive public relations going on here. There's too much vilifying. If you go to Google and search for light squared GPS and jam, the last time I looked, you got 180,000 hits. Jamming is a very subjective term. Is light squared trying to jam GPS? I mean, these are things that we see in the Republican-Democratic budget debate, that type of polarization. Or we see the pro-life, pro-choice debate, that type of polarization. There are problems going on here. If light squared did a stupid job engineering the system, there would be interference to today's population of GPS due to desensitization and overload. Jamming, we don't need words that are analogous to pro-choice, pro-life issues. Let's try to make this, a public interest debate and balancing what the best way is to use the spectrum. My car GPS will not suddenly stop functioning a year from now. I can assure you that the forces at FCC and NTIA are such that the GPS in my car will not suddenly stop working 12 months from now. There is a lot of inertia in this system.
So you give a good analogy with the Republicans and the Democrats as they go through their budget debacle right now. There's a working group going on right now with Light Square and the GPS as they try to negotiate out a solution. And I know that they've tried this in the past to have different groups try and negotiate on the side and then present to the FCC. Do you see that as continuing, or what do you see as coming out of that working group and being ultimately presented to the FCC? And if they might even come out with things more like smart radio as an alternative. In other words, are there solutions, building blocks, like you said, over the next 10 years, but is there an opportunity for them to come out and even say, but going forward, we see even less of this interference potential because of technology that's coming up that's going to be able to smart read various wave spectrums?
I mean, it's two questions. What if you gave a bunch of disinterested people the problem and said, think of solutions? I think if what you said is true, that could come out of that. And for example, in the North Point DirecTV controversy of around 2000, for a variety of reasons, FCC gave a contract to MITRE Corporation,